again. So yeah, looking at this one, we're trying to figure out what kind of shape it is. And again, right away, I can tell you that it's a plane. And this is just because everything is terribly linear, right? There's nothing like fun or jazzy about this problem. There's not even quadratics, right? I don't see any s squared or t squared. I don't see any sine. I don't see any cosine. I don't see anything, exciting about this. It's all just linear stuff. And so if you ask me what is a surface that is entirely linear, right? It's got to be a plane, right? The plane is a nice linear surface. But still, we would like to be able to verify this. And the way that we verify these is transforming them into a coordinate system that we know and love, Cartesian, right? And so let's go ahead and spend a little bit of time and transform this into a Cartesian equation. I know that this right here is x, this right here is y, and this right here is z. So in particular, the x and the z equations are quite nice, right? This just says x is equal to 3s and z is equal to t. If we'd like to, we can even rewrite this one here as s is equal to x over 3. And the reason why I do this is because, again, we're trying to get a Cartesian equation. Y, the most complicated equation here, says y is equal to 4t. Oh, I must have done a bad job. What was it? Was 4t or 4s? One of these was supposed to be an s. You happen to remember?
It's TS.
So 4t minus 2s, like that?
Yeah.
Awesome. Thank you so much. So yeah, 4t minus 2s minus 1. And now I can go ahead and plug these things in. Instead of s, I'm going to write x over 3. Instead of t, I'm going to write z. So this gives me y is equal to 4z minus 2x over 3 minus 1. And so now this is certainly looking like a plane. If you wanted to, you could rearrange it one more time, right? And I could write this as 2/3 x plus y minus 4z is equal to 1. And so now, right, we're back in like 12.5. I could ask you to tell me what is a normal vector for this plane and all that fun stuff. But yeah, once we have it in Cartesian, we can stare at it and say, that's definitely got to be a plane.
I had all of that, but when I kept reading it, I kept reading that there was a square above the z and the x for no reason.
Yep, that would do it, right? Because when you have squares, then you get something that's a little bit more exciting. It's going to be more akin to one of these quadric surfaces from 12.6. But yeah, without the squares or anything, it's just a plane.